Welcome back, mathematicians. So we're going to try to do things a little bit differently here. I've got an iPad set up, so it's not just using my hands and the book. So now I have kind of a digital version of where I want things to be set in your book. This lesson's on understanding direct proportions. So let's just go back and define what a proportion is. So a proportion, and this should be review, okay, is when two ratios are equivalent. Okay, so for example, 1/2 is equal to 2/4, right? Now, I have an equation here, so this is like a proportional equation. When we talk about direct proportions, we're now talking about an equation where we have two variables that equals a ratio. And each of those variables represent something different. It kind of depends on the situation that you have. And we're going to get into these type of word problems where we have situations like volume of water and number of fish and how those vary directly and how they're proportional. But first, let's go over some definitions. So I'm going to keep going. Now we're going to go over what's called the constant of proportionality. And this is kind of like a unit rate. And a lot of times it's referred to as the COP, okay? And its variable is K. So in an equation, if we say we have some ratio y over x, where y could be like the volume of water, x could be the number of fish, so it doesn't have to be just y and x, but if that equals k, another way that we can write it is y equals k, which is that constant of proportionality, times x. Okay, and so we use these a lot of times to graph, which we'll get into the next section, where we have an x and we have a y, and we can find different points about where the situation varies directly. So if k was, say, 2, it would be saying that y is always 2 times x. Or if k was 5, it would be y is always 5 times x. Like you always have 5 times that amount. So you see that a lot in ratios, and you actually do this a lot in your head. You just don't really understand it. You don't recognize that you're doing it. So now we're going to put that onto paper. And we'll start with example 1. So for example 1, it says a pet store owner uses a table to decide how many of a certain type of fish to put in an aquarium. Tell whether the number of fish, F, is directly proportional to the volume of the water, G, gallons. If so, give the constant of proportionality, remember that's K, and tell what it represents in this situation. Then write a direct proportion equation. Okay, so in this case, we don't have a y and an x, but we do have fish and the amount of gallons. Okay, so we're trying to figure out some sort of ratio and see if that ratio is consistent throughout the whole table. So let's start out by kind of labeling what our variables are going to be. So we've got fish, okay, and we can call that F. And then on the bottom, we've got gallons. We just label it G. So as I look through each of these different ratios, I see I have 6 fish, to 4 gallons. And what I want to do in this table is I want to see if this ratio is equal to all the other ratios that are in there. So what I want to do is I want to see if this ratio is equal to all the other ratios of the fish that are in there. So is this equal to 15 over 10? Right? Is that also
Equals 30 out of 20.
So in each case, all of these, if I were to reduce this fraction, 6 over 4, right, is 3 halves. This is 3 halves. This is 3 halves. Okay, which is also equal to 1.5. Okay, what they reduce to, that's what our constant of proportionality is. Okay, or our COP. It's just saying how much they vary directly, right? How many fish compared to how many gallons. So all it is a comparison, and then we can use this comparison to make a graph. Like say we want to extrapolate and want to say, well, what about 60 fish or 100 fish, right? There's a lot of fish that you could put in. Okay, so that's really what K represents. So K, yes, it's the constant of proportionality, but what it represents is how the number of fish uh, relate to the amount of water that you have in that in gallons. And so now we're asked to write a direct proportion equation. So we have the two variables f and g. Remember, our direct proportion equation is y equals k times x. In this case, we don't have y, right? We have f, and we don't have x, we have g. So what we're going to say is that f is equal to, and our constant of proportionality was 1.5 g, right? So the number of fish is 1.5 times the number of gallons of water. And that's how you would find, how many gallons of water you'd need for 100 fish. Okay. And our second example is the table shows the distance traveled by a snail, d centimeters after t hours. Tell whether d is directly proportional to t. If so, give the constant of proportionality and tell what it represents in this situation. Then write a direct proportion equation. Again, so we want to take this and we want to say if these ratios are all equal to each other. So sometimes students can get confused on what goes on the top and what goes on the bottom. For example, do you write distance over time or do you write time over distance? And what you want to think about is what depends on the other. Does the distance you travel depend on the time, or does the time depend on the distance you travel? Okay, so in this case, the distance depends on the time. So when I make my equation, I'm going to put distance on top and time on the bottom. And we'll see if each of these ratios are equal to each other. Because if they are, then it's proportional and we can make a direct proportion equation. And if it's not, we can actually just stop there. There's nothing else we can do because they're not proportional and they don't have a proportional relationship. So let's take a look. Our first one is 9 to 1. Our second one is 18 to 2. So it's looking good so far. And our next one is 21 to 3. And if I reduce all of these fractions, well, 9 over 1 is going to give me 9. 18 over 2 is going to give me 9. So these are equal. 21 over 3, though, that gives me 7. Right? They all have to be equal for it to be proportional. Okay? So for y to be directly proportional to x, the ratio has to be the same for all of these pairs. So in this case, because they're not proportional, there's no equation. And we can say that because the time does not vary directly with the distance traveled. And if we keep going down further, we have another example here. Tell whether each equation represents a direct proportion. If so, identify the constant of proportionality. So remember, that is just k. Right. So our direct proportion equation is y equals k times x. So in all of these situations, we have to get y by itself. So it's all the way back to solving equations. We want to get the y alone. So right here, what is happening to the y on number 1? Right now, it's being multiplied by 1/2. So if I want to get this all the way down so that it looks like y equals k times x, or some number times x, what I'm going to do is I'm going to multiply both sides by 2/1, because that is the reciprocal for 1/2. And I'm going to do that to both sides. I'm just going to write it kind of in between the 3 and the x. I don't want to write it over here because then it looks like I have x smushed between two different numbers, and really I'm multiplying these two together. So what happens is these cancel, and I'm left with y equals, and then here I've got 3 times 2/1, which is 6, and then x. So my constant of proportionality, or k, would be 6. So in all of these instances, I'm just trying to take the equation that I'm given and make it look like y equals some number times x. And that some number is your constant of proportionality. It's kind of like your unit rate when you go back to 6th grade. Now let's go down a little bit and look at the very last one here. So again, I want to get this so it's y equals kx, right? So I want to get y by itself. My step would be to add 2 to both sides. When I do that, these cancel, right? And I'm left with y equals 5x plus 2. Now notice how there's a difference here, right? What I want it to look like is y equals some number, right, which would be k times x. And I have all of that. However, I can't have a number here. Okay, so there can't be any adding or subtracting at the end. Okay, otherwise they are not proportional. It's not a direct proportion. Okay, so our answer here would be not a direct proportion. And now let's go ahead and turn the page. So for these next two on your own problems, you're being asked to state whether y is directly proportional to x. Remember, that's just saying whether or not the ratios in the table are equal to each other. So that's for number 1 and for number 2. When you finish that, get that checked by your teacher, you can move on to the next two example problems. And we've got one more problem. So here the table shows the price P dollars for X cans of soup. P is directly proportional to X, so they're telling us that it's directly proportional. Find the constant of proportionality and tell what it represents in this situation. Then write a direct proportion equation. Okay, so what we want to find out is what that ratio is. So again, we want to figure out which variable goes on the top and which variable goes on the bottom. So let's do that. Which one depends on the other? Does the price depend on the number of cans you purchase, or does the number of cans you purchase depend on the price? And you can make a case for both instances, but usually, right, the price that you pay depends on the number of cans you get. So what you were looking for in our constant of proportionality is the unit rate. And that's that reduced fraction. Okay, so we want to find the unit rate. So what we do is we take our variable for price and cans, and we'd say, well, it's $1.60 for one can. And I'm just getting that information from right here. Okay, actually, I don't want to use red for that one. I'm just getting that information from right here. Okay, and what that means is that for each can, which is the variable for x, you pay $1.60, which is the variable for p. Okay, so there's kind of a phrase where it's almost like you fill in the blank here for when you're asked to define what the constant of proportionality represents in each equation. And I'm going to write that phrase right here. Okay, and that's just for each x variable, right? In this case, it was number of cans. You have, sometimes it's you pay, sometimes it's you get, but usually it's something like you have this amount of y variables. Okay, and so that's the general expression that we use, that phrase for kind of bringing it all together. And of course, we want to look back at this problem here because it also says write a direct proportion equation. And while we kind of did that, right, this isn't really a direct proportion equation because we have to write it as y equals kx, right? It can't be p over x equals some ratio because that's just a proportional equation. We want to write a direct variation equation. So we're going to bring this down here, and we're going to say p over x equals 1.60 over 1. And then I want to move this x over here. I'm going to multiply both sides by x. What happens is those cancel. And I've got p equals 1.60 x. And we don't have to really write over 1 because anything divided by 1 is just itself. So that would be my answer right there if I were asked to write a direct variation equation. And lastly, you have these three problems. You're asked to see if number 3 and number 4 represent a direct proportion equation. Some of that's just y equals kx, where you can't have any addition or subtraction. And then in number 5, you're asked to state what the constant of proportionality is. So they're telling you that it is an equation. You're asked to write that equation and then state what the variables mean. And remember, for that last part, it's usually the most difficult part, but you're just kind of plugging into that statement, that blanket statement that I gave you earlier. And when you're done with these three, show your teacher and you'll be ready for the problems in the textbook.